Let's prove this statement. For all real numbers x and y, the absolute value of x times the absolute value of y equals the absolute value of x times y. Now let's start by looking at the definition of the absolute value. For any real number x, the absolute value of x, denoted by x with bars on the sides, is defined as follows. If x is greater than or equal to 0, we use just whatever x is. But if x is negative, then we multiply x by -1 to flip the sign to positive, so that no matter what, the output of this absolute value is positive. So if you notice, the definition of the absolute value of x depends on whether or not x is negative. So when we prove this statement, we should split our proof into cases based on whether or not x or y is negative or not. Let me explain. Since we're proving a universally quantified statement on x and y, let's instantiate x and y as arbitrary real numbers. Now, since we're using the absolute value of x and the absolute value of y, we're going to split this proof into 4 cases. For case 1, we're going to assume x is greater than or equal to 0 and y is greater than or equal to 0. That way we can clearly identify what the absolute value of x is and what the absolute value of y is. Now, since x and y are both non-negative, that means that if we take the inequality x is greater than or equal to 0 and multiply both sides of this equation by y, since y is non-negative, then we would get, by algebra, then this means that x times y is greater than or equal to 0 times y, which is just 0. So that means x times y is greater than or equal to 0, and that means we'll clearly know what the absolute value of x times y is. Now, since x is greater than or equal to 0, that means the absolute value of x is equal to x, since x is already non-negative. We can make the same claims about y and x times y. So that means the absolute value of y equals y, and the absolute value of xy is just xy. So then that means that the absolute value of x times the absolute value of y equals x times y, which is the same thing as the absolute value of xy, which is what we wanted to show. Now, this is just for case 1, where we assume that x and y are both non-negative. We have 3 more cases to go. So next, we're going to assume x is negative and y is non-negative. Now, just to speed things along, I'm going to sketch the rest of the proofs, but they're basically going to look the same as case 1. So in this case, the absolute value of x is negative x, since x is negative. The absolute value of y would be just y, since y is already non-negative. And then if we want to get x times y, we can take this inequality here and multiply both sides by x. But if we do that, we have to flip the inequality, since x is a negative number. When you multiply an inequality by a negative number, you have to flip the inequality symbol. And 0 times x equals 0. And so now, regardless of whether or not x times y is strictly less than 0 or less than or equal to 0, either way, this means that the absolute value of x times y is equal to negative xy. Whatever xy is, if we multiply it by -1, we can flip the sign to be positive. And from here, you can see that the absolute value of x times the absolute value of y is the same thing as the absolute value of x times y. Now, for case 3, it says assume x is greater than or equal to 0 and y is less than 0. If you notice, this looks just like case 2, but the letters are backwards, which means that the proof is going to look exactly the same, except all the letters are going to be flipped. So I'm just going to put same as case 2. Let's swap the letters x and y. And finally, for case 4, we're going to assume x is negative and y is negative. In this case, the absolute value of x is negative x, and the absolute value of y is negative y. And if we multiply both sides of this inequality by x, we get xy is greater than 0. We have to flip the inequality, since multiplying both sides by a negative number here requires us to flip the inequality symbol. And this means that the absolute value of xy is just xy. And the reason why the statement is true is because if you multiply negative x times negative y, you get positive x times y. And so now we have proven that the statement is true regardless of which case we assume. For all 4 cases, our assumptions were all mutually exclusive. But regardless of which assumption we make, we end up with the same conclusion. Therefore, we have proven that the statement is true for all real numbers x and y. Thanks everyone, and I'll see you in the next video.